Okay, we're now looking at 7c.2. I can solve a real-world problem by multiplying polynomials to identify the solutions of a polynomial. Okay, example 1. Use your calculator to find the solutions of the following polynomial functions. Oh. So using our calculator to find solutions we've already done it. It's literally just doing x-intercepts. Remember, your solutions are also your x-intercepts. So if I open a new document, no, I don't want to save. And we're going to add our graph. So we have 5x cubed plus 21x squared minus 21x. Ooh, I didn't finish writing it. Minus 5. Okay. I can, remember, we go to menu, analyze graph, and our zeros. So solutions, x-intercepts, zeros. Remember, all of those are really talking about the same thing. Then we use this trackpad, right, to move it. I'm just going to use my own computer mouse to move it. It's a little bit easier. It doesn't really work with the touch screen as well. And we can start finding those. So there's one at -5. If you do just kind of go over it without hitting enter again, they kind of pop up. So we have one at -5, one at -0.2, pop the other one over, there it is, and 1, 0. Okay. So I'm going to put those in here. The only different thing is now that their x-intercepts are points, but solutions are x equal. So we ignore the y, and we're just pulling out our y value. So that's the biggest difference between solutions and x-intercepts, is the x-intercept is the point on the graph, where the solution is what x itself equals. So a very minute difference, but you find them the exact same way. Okay? I'm not going to even worry about b. We've done a lot of those. I think it's the easier part of it, and we'll do it in some of our examples as well. So we'll get it a second time there. All right, let's look at example 2. Okay. Given the factors, we want to write the polynomial, and I'm going to add a direction here in standard form. Okay. So if I have factors, all I'm doing with those factors is I am multiplying them. Okay. This was one of the first things we did in that factor review packet. We had kind of our distributive property and our multiplying property as part of it. So we've kind of reviewed it a little bit. So when you have just two, it's very easy. If you remember FOIL, or we're just distributing twice. So I like doing our first 2x times x, which is 2x squared, our outer. 2 times -5 is -10x. Our inner, -1 times x is -1x. And then -1 times -5 is +5. Okay, so I do 2x times x. 2x times -5, so I do the first one times everything after, then I do the second one times everything after. Okay. So now all we have to do is combine our like terms. So if you look at our middle terms here, -10x and -1x, we can combine those. We bring down the 2x squared, -10 and -1 give us -11x. Plus 5. And that is our answer. Alright, now we're going to look at our second one, x minus 3 times 3x plus 1 and x plus 1. So if we're given these factors, the first thing we do is just write them all out. We're multiplying them. Okay? And when you have 3 factors instead of just 2 factors, you can only do 2 at a time. Okay, think about, right, 2 times 3 times 5. you don't just try to multiply it all together. You usually do 2 times 3 is 6, 6 times 5 is 30, right? So you multiply the first two together first. Okay. So we're going to do the same thing here. So I have x, right, the first times the second, or the first times the first. X times 3x is 3x squared. And then the first times the thing, the other thing in this second parentheses, x times 1 is 1x. Then we have negative 3 times 3x, which is negative 9x. Negative 3 times 1 is negative 3. Now, we still have this x plus 1 back here. Okay, it didn't go away, we just didn't use it yet. Now, same thing, I want to combine my like terms, right? I have a positive 1x and a negative 9x. So that's 3x squared. Now I have to multiply again. So this is where FOIL breaks down the acronym, first, outer, inner, last. That's why I kind of did this one with, I took the first thing here and multiplied it by both of these. Then the next by both, then the next by both. Just make sure you have a pattern that you use so that you don't miss anything. Okay. So the first times both of these, 3x squared times x is 3x cubed. And 3x squared times 1 is 3x squared. Then we have negative 8x. That's like a weird thing here, looks like a negative with that x. Then negative 8x times x is negative 8x squared. Negative 8x times 1 is negative 8x. And then this negative 3. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. Okay, so I did this times this times this. Then we went on to this one. This one times this one, this one times this one. Then we went on to the next one. This one times this one, this one times this one. So you just have to make sure everything gets multiplied by everything else. Now, looking for like terms, I have x squareds here. And I have x's here. So that gives me 3x cubed minus 5x squared when I combine these, minus 11x minus 3. And that is how we get it in, again, in standard form instead of what we would call like a factored form. All right, let's look at our next example. Our next example kind of combines what we did with example 1 and example 2. Okay. So the volume of a box is 74 inches cubed. The width, the length, and the height of the box are x, x plus 4, and x minus 1. What is the value of x? Okay. So we're going to start with, right, we know the volume of a box, right? This is what a box looks like. Right, volume is length times width times height. Right, we did that last semester as well. So with this, I'm just going to substitute in. I know my volume is 74. I know my length, width, and height. It starts with width. I always do, it doesn't really matter the order. I like to put the x first. It's the easiest with when you distribute. Makes it easier. So now, again, we're doing the same thing. I'm just going to slowly multiply two things together. This 74 is just going to hang out over here until we're ready for it. Okay. So I have x times x and x times 4. Okay. If you multiply by that x first, super easy and convenient. You don't have to worry about too much when you just have an x there. Now, I can multiply these two together. Again, that 74 is still just kind of hanging out. Now, doing x squared times x, which is x cubed, x squared times -1, 4x times x, 4x times -1. And here, we want to make sure we combine our like terms. So 74 equals x cubed, -1 plus 4 is -3. Okay. Now, we're actually solving for x, and we're going to do this the same way we did our first ones by graphing, but and finding our solutions, but it has to be equal to 0. So we just have to, now we just have to subtract that 74. So we have 0 equals x cubed minus 3x squared minus 4x minus 74. These are not like terms. One has an x in it, one does not. I'm going to type this into my calculator. So we have x cubed minus 3x squared minus 4x minus 74. I keep doing that. Minus 74. I see only 1 0. This looks like just a line, but if you zoom out, which you don't have to, but you can usually eventually find where it curves, but it doesn't really matter. I can see my x-intercept there just great. So I'll go to Menu, Analyze Graph, 0, to the left of it, to the right of it. It keeps wanting to drag around, sorry. Okay. And you should get 5.85. So again, finding your solution, what x equals, is the same as finding your x-intercepts. So x equals 5.85. Now, what are the dimensions? I actually want to know what the width, the length, and the height are. So my width was just x, 5 inches. Okay, that comes from here. My length was x plus 4, so that's 5.85 plus 4. And our height is x minus 1, so sorry, I got ahead of myself there. 5.85 minus 1 inches. Okay. So that last step should be super easy. You're just kind of plugging in for x. And again, that x minus 1 comes from that one. Okay. All right, go ahead to the page. We're going to do one more example, pretty much the same. This one's a cylinder, however. So the volume of a cylinder is, I don't have a volume. We're going to make it 137 pi centimeters cubed. I don't know. Okay, so what is the value of x? We're going to start the problem the same way by writing out our volume formula. Volume of a cylinder is pi r squared times height. So our volume is 137 pi. That's an odd pi symbol. That's all right. Equals pi times r. Our radius is x plus 1 squared. The first thing I'm going to do is slightly different with this one. I'm just going to get rid of the pi. Right, there's a pi here that cancels, a pi here that cancels. I'm left with 137. Makes it a lot easier to start with. Now, again, everything's just going to kind of come along. 137 equals. And I'm going to start with our squared. Remember when I square something, x plus 1 squared is really just x plus 1 times x plus 1. So again, bringing everything along. I'm actually going to multiply these now. X times x is x squared. X times 1 is 1x. I have 1x here. 1 times 1 is 1. And again, this x plus 6 comes down. All I have to do now is combine my like terms. So that's x squared again, I need to multiply. So I'll start here. X squared times, the 137 is just, again, still hanging out. So then x squared times x is x cubed. X squared times 6 is 6x squared. 2x times x is 2x squared. 2x times 6 is 12x. 1 times x is 1x. 1 times 6 is 6. Okay. So again, what am I combining? Right? And then I can combine these. My last step set equal to 0. Cubed plus 8x squared plus 13x. And 6 minus 131 is negative 1, or sorry, 6 minus 137 is negative 131. Okay. So now, figuring out what x equals. Menu. Nope. New document. Add graphs. We have x cubed plus 8x squared plus 13x minus 131. And we only have the one spot where it works. Finding that 0 from here to here. 2.92 is our 0 there. So now, for our dimensions, we have a radius, which is x plus 1, so that's 2.92, plus 1 equals 3.92. This was in centimeters. All right, and that comes from here. And we have a height, which is 2, 6. And that is it. All right. Have a good rest of your day. I will see you guys tomorrow.